So today we will start with a new chapter, chapter 8. The title of the chapter is Network Security. So what is the goal of this chapter? We will try to understand the principle of network security, and under this you will need to know what is cryptography and its actually different uses, or on confidentiality, what is authentication, what is message integrity, uh, and we will also cover some security topics in practice, firewall and intrusion detection system, then security in different layers. So we may actually not look into this thoroughly. That might not be in our syllabus, and we will come to know whenever we are actually covering a topic. Okay. So what is network security? So network security is depends on different criteria. So we will go one by one. So the first one is confidentiality. So in the term confidentiality implies that there will be one sender who intend and there will be one intended receiver, so they should understand the message content. The sender will encrypt the message and receiver will decrypt the message. So this information should not be known to other than the intended sender and receiver. So that actually uh, termed as confidentiality. Then the term authentication. So the sender and receiver want to confirm the identity of each other. So whenever I am talking, the sender is talking to a receiver. Sender needs to understand the receiver is the right receiver, and the receiver wants to understand the sender is a real.
স্যার আপনার কথা শোনা যায় না।
Sorry, I got disconnected for some reason, so my network bandwidth is not correct. Can you hear me, guys?
জি স্যার।
Okay. So let me share the screen. I think that is unshared. So as we are talking about authentication, we are actually we are telling that the sender and receiver want to confirm the identity of each other. So they need to verify first that they are talking to the right person. So that is also very important in case of network security. Then the topic is message integrity. So uh, here the case is the sender and the receiver want to ensure the message is not altered in transit or afterwards without detection. So as we are actually using computer networks to communicate, this computer network is actually prone to it is open to all, as you can see. So from one point to another point in the middle, actually different different adversary element can actually change your message. Okay, so it can actually stop your message, change the message, and forward to the receiver. So this message integrity is also very important in network security. So if the message is actually altered, the receiver should understand that there is some altering of messages. So he should not believe that message, or he should not actually do anything for that particular message. Okay. So the last option, so the next one is operational security. So the organization using the public internet uses firewall intrusion detection system to detect attacks. So assume that you have a software firm where you have some web server. In that web server, actually, you have posted one website. So the people are is actually is having some communication over there, but you have to also find out, you have to identify also that whether there are some actually unwanted communication present or not, for actually attacking purpose, attacking your web server or attacking your servers. So this organization, as you need to be connected with the public internet, there is a firewall system. So the firewall actually is kind of a like is a filter system. Depending on the different behavior, it can actually filter some request. So depending on a blacklisted node, it can stop that blacklisted node's execution. Okay, so that is the operational security. Uh, in network security, actually, all the examples are actually revolving around these three entity: Alice, Bob, and Trudy. Okay, so normally is the actually the idea is Bob and Alice are lovers and they want to communicate secretly. So here these two person is the actually Alice is one part and Bob is another part. That means they are actually one of them is sender and another is the receiver. And you want to actually show the or demonstrate the network situation, that okay, the Trudy is the adversary person or intruder who can intercept, delete messages. And the Bob, as a receiver, Bob should understand that someone is actually changing the intended data, so they need to do take action accordingly. So you will see also that here, if you have to remember that Alice and Bob is the actually right person, right sender, right receiver, and Trudy is the enemy, you can say, or adversary. So in real life, who are the Alices and Bobs? For example, we will use these two entity, but in this case, you can see that they are sender and receiver. So they could be well even a web browser or server for electronic transaction. So in this case, let me understand. So you see that I am a client of a uh, Peekaboo website. Okay, so Peekaboo is a e-commerce website. In the Peekaboo web server is there. So like as Peekaboo web server want to verify me that I am real person Faisal Hussain, using this account is the real person, and he wants to actually protect his user. So I am the same, I am he wants to protect my messages. Okay, so or he doesn't actually, he should not accept any message that has been changed whenever it goes to whenever it reaches to the Peekaboo web server. So here this Alice and Bobs are can be my browser client and or web browser, and in the Peekaboo's actually the server. Okay, so these are the Alice and Bobs. So they have to understand that okay, I am the right person. The message integrity is okay. Then the authentication is done. So and so. Another example could be online banking client server situation or DNS server. As you can, as you already know, the DNS server actually holds all the mapping between the domain name and the IP address. So it can actually give you the IP addresses for a particular domain, like facebook.com. What will be the IP address of that particular address? So the DNS server actually plays a great role while you are browsing. So this DNS server can be actually attacked again to take you to a different IP address. Assume that Facebook's IP address is this one, but another malicious person want to actually take you to another IP address instead of the real IP address of Facebook. He can actually just change the attack the DNS server and change the IP address there. So your device will assume that this is the right Facebook account or right Facebook address. So he will actually put his username and password, and voila, your information is leaked. Then router exchanging routing table updates. These are the example of Alice and Pops. Actually, in other words, you can say they are the intended sender and receiver, and there are bad guys out there. So what can a bad guy do? So a lot of things can a bad guy do. That means if I want to actually have an impact on a normal conversation, what I can do. So first one is eavesdrop. So sniffing and recording messages. That means whenever actually A and B is communicating, Alice and Bob is communicating, uh, I am Trudeau, I can actually eavesdrop to this message. So if the message is not properly encrypted, I can already know that what is A and B is communicating, because they are actually using a public medium because of the computer network. So a truly adversary can actually eavesdrop on it. Then actively insert or delete message into the into connection. So what I can do is actually actively change the message. So whenever the message is going, it stops the message. That means T will stop the message. It will not forward the message to B directly. So and it changes the message and forward it to B. So just to mimic the effect that though it is sending from Trudy, but it will actually assume that it is coming from A. Okay, so it can insert or delete message into the connection. So next one is impersonation. So it can fake or spoof. Spoof is the another terminology meaning fake. Spoof source address in the packet or any field in the packet. So you remember that in the IP address and in the MAC address, normally actually if you look into the IP address, you give your source address, isn't it? So that the receiver can understand who is sending the data. But instead of actually sending the IP address of mine, because IP address is actually is written by the written by the network layer. So I have the I can change my network layer rule and make my IP address to someone or IP address of my boss. Assume that I'm actually changing the IP address of my changing my message into IP addresses of my boss, and after that I'm forwarding the packet. So in future actually the packet can be actually checked out, and it might see that actually I am using the packet is coming from my boss's IP address, but it was not true, it is fake. But again, this can be actually there are countermeasures. Okay. Then hijacking, so take over ongoing connection by removing sender or receiver, inserting himself. Denial of service, which means that you are requesting for the resources for enough resources that the resources are not free, and the actual connection cannot be actually established because the resources are not present. Okay. Now we'll talk about principles of cryptography. So cryptography, the discipline of coding or encrypting or decrypting or hiding the message from the third party indicates cryptography. Okay, so two important term is cryptanalysis. It is actually the process of deciphering the encrypted message, and cipher. So this is a method of algorithm of encrypting the data. Okay, so you can actually the cryptanalysis is means that you have an encrypted message and you are trying to find out a way to decipher it. So that is the like crypto analysis, and cipher is the method of encrypting the data. So you just in many cases one algorithm is called this cipher. Okay, Caesar cipher and so and so. So let's see the language of cryptography. So how you can represent a cryptographic language. So assume that the message that you sent is called a plain text, and Alice have some actually encryption key. So this encryption key is nothing but a actually you can assume that it's a key value, a value which is used by an encryption algorithm, and it takes the encryption key and it takes the plain text and encrypt the value of the plain text, and which is known as cipher text, and is sent over to the decryption algorithm. And the Trudy in between actually trying to actually take over the cipher text, but if she doesn't know how to decrypt this plain text, sorry, the cipher text, she cannot actually understand anything from this topic. Okay, so she cannot understand anything from this message. So it will be actually ensured, or the message integrity is kept. Okay, so in the Bob side, Bob has a decryption key. So this is actually this Alice's encryption key and Bob's decryption key are related. So this KA and KB is related. We will see that for different type of cryptography, this K and KB's relationship will be discussed later on. Okay. So assume that there is another decryption key. So this is used to decrypt the message of the cipher text. Okay, so it will pass the decryption algorithm pass, and the KB and the actual plain text will be extracted out, and the Bob can read it. So we are assuming that the Strudy don't have this Bob's decryption key, because this decryption key is required to extract the actual plain text from the cipher text. So this is written in this way, that there is an M plain text message which is represented by M. So whenever you say that you are encrypting it, the indication or notation is this one, that Ka of M. That means you are actually making you can assume that this kind of function. So the value, encryption algorithm takes a Ka value, so that's why you are writing Ka in bracket M. So this is indicated by C, which is a ciphertext, stands for ciphertext. And now if you want to know what is the value of actual M, so you have to make a decryption of this, and that is KB of C. So KB is the decryption key. So it will spit out the actual encryption. So KB KA of M. So you can assume that KB is actually removing the encryption part, and it will be the message will be extracted out. So that's how actually normally any representation is given. So we will see that the later on. Two types of encryption key is very popular. So first one is symmetric key cryptography, and another is asymmetric key cryptography. So from the name you can understand that it actually it is dependent on the key value. So we can actually we already saw that there is a key pair. That means one is for encryption and another is for decryption. So this encryption key and decryption key, if these two keys are same, then you will say symmetric. So that name actually suggests the idea. if they use the same key, that means there is called a symmetric key. Another term is used called shared secret key for both encryption and decryption. So what is a decryption key? So and it makes sense to many of you. Like if some actually key is used to encrypt, like in a function, it takes a value, it does some mathematical operation on the plain text, and it gives you the encrypted text or cipher text. Then it should have the same key to actually decrypt it and get the plain text again. So this makes more sense of the symmetric key. Another group of or another class of cryptography is asymmetric key. So actually, from a mathematical derivation, it is found that there could be two different keys or a key pair. For one encryption key, there is another unique decryption key, so which is not same. These two keys can is used to encrypt and decrypt. And from mathematical derivation, this is found that this is also possible. This is also known as public key cryptography. So what happens uh, in this case, the encryption key is available to all of us. Okay. So where is the scenario? So that is called a public key, and the person that is actually trying to find out what is the value of it is and he will use the private key. So it is actually, you can give a diagram in this scenario that, okay, you have a box. Okay. So this box actually store the message for Facebook. So we are actually giving the example of Facebook always, so this is easy. So like you have there is actually one key where it is used to insert the message. Okay. So as a user, you actually write some message and put it on the box using this public key, which is available to all. Facebook has actually declared this public key to all. Okay. So you truly, everyone knows this public key, so your adversaries knows the public key, but the private key is not known to all. It is known to the only the receiver part. So what happened is, this box is actually a special kind of box. It cannot be it can be actually inserted the data. Whenever data is inserted, whenever you actually close this actually door, it cannot be opened from this side. Okay. So this data can be opened from another side, which is called the private part. So using a private key, you can use the receiver can actually extract the plain text. So that makes it more usable, that everyone can actually encrypt the message, but only the one person can decrypt the message. Okay. So that is the case of the public key cryptography. Do you have any question up to now? No. So now we will talk about symmetric key cryptography, known as Caesar cipher. So the Caesar cipher is actually came from a person called Julius Caesar. So we will not go into history. If you want to know the history, you can actually look for it in YouTube. Also, you can actually learn different actually interesting history. So this would work by taking each letter in the plain text message and substituting the letter, that is k letters later. Okay. So what is the idea actually? Let us actually see from the example. Okay. So the example you can see here. Okay. So you have all the letters, as in that we are actually writing the plain text with the alphabet. There is 26 letter in English alphabet. So for every letter, actually you have a substitution value. Okay. So the easier one is actually, if you assume that, okay, what will be the what will be it is, if it is shifted. Okay. So you see that from M the value is written in this way, mn, then b. So that means for each of the actually letter, the another variable is actually another letter is chosen. Okay, so that is in this way actually uh, uh, the this can be shifted. So let us go to the scissors cipher plain text. So in this case actually this is also more easier. So like if I just write the example here, a b c d e f. So this is the actually serial of alphabet. So yeah, so here there will be a value called k, which value is 3. So it means that it will be shifted by 3. So what do I mean by shifted by 3? So this letter will be written in the following like this: d e f g h i and so on. Okay, so that means it is shifted. A will be replaced by d, b will be replaced by e, c will be replaced by f. So you can see there is a shift of the value 3, or the k is called shifting value. So whenever you want to write Bob, I love you, Alice. So this will be converted here. B is converted to E, O is converted to R. If you just check, then you will see the result. So in this case, if I ask you to write a plain text or find out the value of a cipher text with the gibberish value, and if I ask you that the shifting value is 3, you can identify, you can just write down this a b c d a to z and shift these letters and find out the result. Okay, so in this way actually you can find out the plain text from a cipher text. So now assume that you don't know the shifting value. That means your adversary or truly the attacker might not know the this value. So uh, is it possible for him to guess if he already knows that you are using CSI? He already knows you are using this technique, so he will try to do what? He will try to find out the value of the shifting key 1 2 3 4 5. In this way he will try out. So there's only 25 possibilities, there is not more. Okay, so these 25 possibility, if he just try 25 times, he can try to find out the result. So it is actually very easy for a program to find out what will be the candidate value. So one of these 25 makes sense, and that will be the your cipher shifting value. So so this is very easy actually encryption method, and this is very breakable encryption method, you can say. So we have already talked about this idea that symmetric cryptography, where you use the sorry you use the same key. In this case, what is our key? Caesar cipher. The key is the shifting value. So shifting value is 3. So that is the that should be known by the Bob, and he will decrypt by shifting in the left in reverse direction. Okay. So in one direction it will be shifted by the encryption algorithm, and decryption algorithm will shift in another direction, and he will find out the result. Okay. Now, the symmetric key cryptography, so the Bob and Alice has the same key, KS. And so the question is how Bob and Alice will agree on the key value. So there are some techniques of you sharing the keys, shared key. So there are some protocol to share this key. We will not actually look into it. Rather, we will just say, we will just know that there are different techniques to share the symmetric key in between two person. Okay, in between sender and receiver. So this key of knowing substitution pattern is also known as mono-alphabetic substitution cipher. So this is again a class of encryption. So there are different techniques of mono-alphabetic substitution cipher. So one of them is normal shifting. That means shifting all the variable, all the alphabet by some value. So here the value was what? 3. So A is converted to D, B is converted to E, C is converted to F in this way. So in this case, so what is a simple encryption scheme? The substitution cipher, substituting one thing for another, or mono-alphabetic cipher. So mono means one. So an improvement on the Caesar cipher. So any letter can be substituted for any other letter. So instead of using the key value shifting key 3, rather you have to know all the substitution value because they are randomized. So if they are randomized, the possibility of cracking this encryption will be higher. Okay. So for because he cannot guess only 25 times only, he have to guess more. Okay. So you can say that this is actually saying that random shifting key for each of the alphabet. Okay. So for unique there will be an unique substitution letter. So for example, here we were seeing that if the alphabets are written A to Z, and for A the value is M, A, B the value is N, and C it is not O. That means it is not Caesar cipher. This is a monoalphabetic cipher. So here actually for each of the letter, a random another unique letter is chosen. Okay. So again, if I just give you this actually plain text and cipher text, that means this mapping for A, what will be the value? I think you can identify what is the what will be the cipher text for the plain text value. This one. So in this case, the encryption key mapping from set 26 letter to 26 letter is done. And what is the order of actually order possibility? It is order of 10 to the power 26, because it could be we need to find out this particular mapping, and from the permutation rule of permutation, you can actually find out the value, the number of actually possibility is 10 to the power 26, which is far better from 25 value. So if you run a program, even it will take a few minutes, few seconds time than 25, isn't it? So like Caesar cipher can be undone by normal human calculation, but here you need some possibility that you have to go for a computer calculation. So still this is an idea, but this is not a great idea for a computer network encryption purpose. Okay. So let's see the last topic of today, breaking an encryption scheme. So you can actually use a ciphertext only attack. That Trudy has ciphertext she can analyze. For somehow, if Trudy can find out, if Trudy can actually intrude on a communication and find out what is a ciphertext, and it tries to analyze it. So there are different analyzing process. So first of all, that could be a brute force. That means that's what we are talking for the Caesar cipher. It has to actually look for 25 times. One of these 25 times he will be successful to find out what is the search key. And for another is the actually for monoalphabetic substitution cipher, it will take some time, but still you can actually write a piece of code and try to find out the value. So for this is one technique of this is one of the technique of breaking the encryption scheme. Second one is the statistical analysis. So there is some trend for English letter, English language. The value, the alphabet E and alphabet T is actually comes at a very higher rate. So what happened is from a block of ciphertext, you will try to find out which letter is coming again and again. You can assume that as E or T, and you can find out what is the value, what is the shifting key, and try to decipher the value. So that is an idea. Depending on the statistical analysis, you can guess it, which is actually time efficient than the brute force. In brute force, you will actually try to choose from all the possible things, but in case of statistical analysis, you are choosing the best candidate. Okay. Second one is known plain text attack. Trudy has a plain text corresponding to a ciphertext. If Trudy has a plain text corresponding to a ciphertext, he can easily break it, because in case of monoalphabetic cipher, it directly find out the actually pairing between A L I C E B O BO, these letters, because it says that Alice I love you. So so this letter can be actually find out from that text, and it already knows the pair. Okay, it doesn't know about the other pair, but it is actually advanced to that particular case, and it can guess on the actually, it can actually use that mapping to another ciphertext and try to find out the trying to find out unknown value. Then chosen plain text attack. So this is another idea that Trudy can actually take. That Trudy will actually can get a ciphertext for a chosen plain text. If Trudy has some way to find out what is the ciphertext of a plain text, he can easily find out. He can actually send a message like a brown fox jumps over some fence. You know the idioms that hold all the 26 letter. So he can send that particular plain text to the user, and if that user is actually not protected, if it actually convert that into a ciphertext and sends it back to the Trudy, then Trudy already know what is the encryption scheme that he is using. So that will be all for today. Now you have actually stop the recording.